In this video, we are going to solve an assignment problem by using Hungarian method. So here we have an example. Find the assignment which minimize the total of the project cost. Each contractor has to be assigned one job. And we have a matrix. In that matrix, 4 contractors, that is A, B, C and D is given. Similarly, 4 jobs, J1, J2, J3 and J4 is given. And these are the cost values. We have to find the assignment which minimizes the total of the project cost. So first we have to check whether this problem is balanced or unbalanced problem. So for that we have to calculate number of rows. How many number of rows? A, B, C, D. 4 rows we have. So number of rows equal to 4. Similarly, we have to calculate number of columns, that is J1, J2, J3, J4. So 4 columns. So both are equal, therefore it is balanced assignment problem. Now we have to do the row reduction method. So that is step 1. So row reduction means we have to select the minimum number in each row and subtract it from all the elements of that same row. So in the first row, minimum number is 15. We have to subtract the rest of the elements. So answer 15 minus 15, that is 0, 27 minus 15, next 35 minus 15 and 20 minus 15. Next in the second row, minimum value is 17. So 21 minus 17, 29 minus 17, 33 minus 17 and 17 minus 17, that is 0. In the next row, minimum is 15. Now subtract the rest of the elements. 17 minus 15, 25 minus 15, 37 minus 15, that is 22 and 15 minus 15, 0. In the last row, minimum is 14. So if you subtract it, get 14 minus 14, 0, 31 minus 14, 39 minus 14, 21 minus 14. After this row reduction, we have to do the column reduction. Column reduction means we have to select the least value in each column and subtract it from all the elements of that column. Okay. So in the first column, minimum is 0. If you subtract, you will get the same values. So 0, 4, 2, 0. In the second column, we have 10, that is minimum. So 12 minus 10, that is 2, 12 minus 10, 10 minus 10, 17 minus 10. In the third column, minimum value is 16. If you subtract 20 minus 16, that is 4, 16 minus 16, 0, 22 minus 16, 6, 25 minus 16, 9. In the last column, we have 0, so that is the minimum. So if you subtract, you will get the same values. After this column reduction step, now we have to find an assignment and optimal solution. So for that, first we have to assign zeros. So first consider first row. In that first row, we have only 1 0. So if we have 1 0, first we have to assign that. So I am assigning this 0. If I assign this 0, corresponding column will get cancelled. Next, move on to the second row. In that row, we have 2 zeros. Okay. So we have to move on to the third row. In the third row also we have 2 zeros. So we have to move to the last row. In the last row we don't have 0. So after this row wise checking, we have to do the column wise checking. Okay. So first consider first column. Already we have an assignment and the rest of the elements are cancelled. Next we have to move on to the second column. So in that second column we have 1 0. So I am assigning this. So this is column wise checking. If I assign the 0, corresponding row will get cancelled. Next move on to the third column. In the third column we have only 1 0. So I am assigning this 0. So if I assign this 0, that corresponding row will get cancelled. Next move on to the last row, last column. In that column we don't have 0 because these two zeros are already cancelled. So after this we have to check whether all the rows have assignment or not. So first, in that first row we have an assignment, in the second row also we have an assignment, in the third row also we have an assignment, but in the last row we don't have assignment. Okay, if we don't have assignment in any particular row, we don't get an optimal solution. So for that we have to do the another step, that is, so we have a few conditions. That first one is select the least uncovered element, subtract it. Second one is subtract it from all the uncovered elements, and third one is add at the intersection of the lines, and then last one is leaving all other covered elements unaltered. So in this matrix, so these values, that is 2, 4, 5 and 7, 9, 7, these values are uncovered elements, and rest of the values are covered elements. And this 2 value 4 and 2, because these 2 points, that is 4 and 2, it is lying on the both lines, right? So this 4 is lying on this side, horizontal line as well as the vertical line. Similarly, this 2 also is lying on horizontal and vertical line. So these 2 points are intersection points, and rest of the elements are covered elements, and this 2, 4, 5, 7, 9, 7 are uncovered elements. Okay, so what is the first condition is given? Select the least uncovered element. What is the least uncovered element? See, 2, 4, 5, 7, 9, 7. The least value is 2. Okay, so now you have to subtract it from all the uncovered elements. So if you subtract, you get, so this row A, column J2, that is 2. So if you subtract, you will get 2 minus 2, that is 0, and 4 minus 2, 2, 5 minus 2, 3, and 7 minus 2, 5, 9 minus 2, 7, 7 minus 2, that is 5. So rest of the covered elements are unaltered. So we have to write that 2, 0, 0 and 0, 6, 0, and in the first column 0, last value 0, and remaining 2 values, that is 4 and 2, are the intersection points. For that condition is add at the intersection of the lines. So using that least uncovered element, we have to add these two. Least uncovered element is 2. So if you add, you will get 4 plus 2, 6, 2 plus 2, 4. Okay. So I repeat, so in the matrix we have to consider the least uncovered element. Least uncovered element is this 2. Okay. So you have to subtract it from the rest of the uncovered elements. So that is 2 minus 2, 0, 4 minus 2, that is 2, and this is 5 minus 2, 3, and 7 minus 2, that is 5, 9 minus 2, 7, 7 minus 2, 5. So remaining the elements are same, and this 4 and 2, that is intersection points, that we have to add with the least uncovered. If you add, you will get 4 plus 2, 6, and 2 plus 2, 4. So after this procedure, we have to do the assignment again. So first consider first row. So in that first row we have 2 zeros. So we'll move on to the second row. First, usually we have to make an assignment with only 1 0 in that row. Okay. So in that first row we have 2 zeros. So I move on to the second row. Second row also we have 2 zeros. So I am going to the third row. Third row also I have 2 zeros. So skip this row, and if you move to the last row, we have only 1 0, right? So I am going to assign this 0, because all the rest of the rows having 2 zeros. So I move on to the last row, I have only 1 0, so I am assigning this. So this is row wise checking. So if I assign this 0, corresponding column will get cancelled. Okay. Next, move on. If now we have to do the column wise checking. So in the first column already we have an assignment. So we have to move to the second column. So I have 2 zeros. So I have to move to the third column. In the third column I have only 1 0, right? So I am going to assign this 0. So this is column wise checking. If I assign this 0, particular row will get cancelled. Okay. Next, move on to the last column. Already this 0 got deleted. So I have only 1 0. So I am going to assign this. If I assign this 0, corresponding row will get cancelled. Okay. Now again we have to move to the row wise checking. So if I consider the first row, already the 0 got deleted. So I have only 1 0. So I am assigning this 0. If I assign this 0, and corresponding column will get cancelled. Now you have to check whether all the rows and columns have assignment. See, in the first row we have an assignment. Similarly in the second row, third row and last row. Similarly, if you check column wise, you have an assignment. So now you have reached the optimal solution. Now you have to find the assignment cost value. So for that we have to consider the main matrix. So for finding optimal solution, so first in the first row, contractor A, we are assigning job 2. So for contractor A, job 2, that is J2, and contractor B, we have an assignment that corresponds to J3. So job 3, and contractor C, here we have an assignment that corresponds to J4. For contractor D, we are assigning J1. Now we have to find the values from the main matrix: A to J2, B to J3, C to J4 and D to J1. So we have to consider from the main table. So A to J2, that is 27, B to J3, that is 33, and C to J4, 15, and D to J1, that is 14. So A to J2 value is 27 and B to J3 value 33, and this is 15 and this is 17. Sorry, 14. D to J1, that is 14. Yeah. So if you add all the values, you will get 89. So this is the minimum cost value. Thank you.